So we've introduced quite a lot of new equations, and there's one more to do, which is the equation of a circle. Let's go for it. Cutting straight to the chase, in GCSE we concern ourselves with circles that have a centre at the origin. So obviously when I say the origin, I mean this point here, which is otherwise known as the coordinate 0, 0. What we say is if a circle has a centre at that origin and a radius of r, so remember the radius is obviously the distance from the outside to the circumference, from the inside to the circumference rather, then it's got the equation x squared plus y squared equals r squared. So if we knew the radius was 3, this would be equals 9. If we knew the radius was 10, this would be equals 100. But it's always x squared plus y squared. So here's some classic multiple choice questions that have come up in some GCSE papers. We've got an equation, x squared plus y squared is 4. So this is r squared, is 4. So our radius must be square root of that, 2. Okay, second one, find the diameter of the circle. So again, we can say r squared is 64, r is equal to 8, and then it wants diameter, which is going to be 2 lots of that, because diameter is all the way across the circle, would be 16. So on the face of it, pretty straightforward equation, I think. What else could they ask? Well, they could do something like this, and I generally think with circles it's a good idea to try and sketch out what they're talking about. Just briefly, so we've got a circle with centre 0, 0 and a diameter of 6, so that's 6 all the way across. So that means that my radius is equal to 3, and that means that obviously r squared is going to be equal to 9. Okay, what about the next one? Well, 25, that's r squared, that's 25. So r is 5. What we want to know is which one of these points are on the circumference of the circle. And this is where we can use another fact, okay? We know that x squared plus y squared equals 25. So let's actually check that. Let's do x squared plus y squared. Remember, these are coordinates. That's an xy, that's an xy. So if we square minus 3, we get 9. If we square 4, we get 16. If we add them up, we get 25. So we can definitely say that this first point is on the circumference of the circle because it matches the formula. Whereas all the other ones, I don't know, something like 40.25 plus 40.25, that's clearly not going to equal 25. This is 81 plus 144, that's clearly, not even plus 144, plus 256, that's clearly not going to get there either. And then 1 plus 144, same problem. So those three cannot be on the outside of the circle because x squared plus y squared, literally the coordinates, do not equal 25. Okay, and the last one. The centre of a circle is 0, 0. In GCSE, all circles have that centre. It's got a radius of 5, whatever it's worth. There we go. Okay, here's an interesting question. The equation of a tangent to that circle at the point 5, 0 is y equals 5. So let's draw our circle. So we know it's got a radius of 5. We know it's centered on the origin. So where does it go through the axes? Well, if the radius is 5, then it should go through the axes at the points which are 5 away from 0. So it'll go through at 5 and 5 and minus 5 and minus 5. And if we think about it, so a tangent is a line that just touches a circle. So let's draw this in blue. So that's a tangent. Okay, and so is that for what it's worth, and so is that. Those are all lines that just touch the outside of a circle. Now we're specifically interested in the tangent at the point 5, 0. So that's the one we've got drawn here because it goes through at this coordinate here, which is 5, 0. Now what's the equation of that line? Well, it goes through the x-axis at 5, so that tangent is actually x equals 5. That's actually a false statement. The tangent that goes through at 0, 5, yeah, that would be y equals 5 because that would be this line going across here. But that's not what it asks. It wants the tangent at the point 5, 0. Lastly, the equation of a circle and the equation of a straight line can have 0, 1 or 2 solutions if solved simultaneously. Now, graphically, solutions is basically the same as intersections. So if we say that they have 2 solutions, we mean they can intersect or cross over each other twice. So basically we have to think, is that possible? If we had just a generic circle, let's sort of rub out what we've got so far. Here's our circle, and if we just drew a straight line, would it be possible to draw a straight line that crosses a circle 0 times? And yes, it would be. There's one. So definitely 0 is possible. Would it be possible to draw a line that touches it just once? And yeah, that would be a tangent. In fact, let's draw that a little bit better. So a tangent obviously only touches a circle at one point. It doesn't go through or into the circle. And then lastly, two solutions, yeah, that line crosses it twice. So all three of those things are possible. Okay, and that's basically it for equation of a circle. Now, what we are going to look at, which makes this a bit more difficult, is the equation of a tangent. Now, this is a classic, I would say, grade 8 at least topic, but it's just using what we've done earlier in the chapter, and it's using a fact, a circle theorem, that if you have a circle, if you have a tangent, and if you have a radius, then those two things always meet each other at a right angle. So that was our tangent, and this is our radius. So here's what we're going to do. I'll use this example to go through it rather than read through the steps, because I think that'll make more sense. So we got this point minus 2, 6. Okay, why do we know it's called minus 2, 6? Because it told us in the question that it's minus 2, 6. We're going to draw on a radius that goes to obviously the center of the circle. And we're going to use the fact that this is a circle theorem, those two meet each other at a right angle. Okay, so here's what we'll do. The first thing we're going to do is we're going to find the gradient of that radius. We're going to do this step 1 here. So how do you find gradient of a radius? You want to do change in y over change in x. Okay, so if we draw a little triangle on here, we can see that that's 6 squares down and 2 squares across. So it's 6 over 2, but it's clearly a negative gradient because it's going downwards, so it's going to be minus 6 over 2. So our gradient here is minus 3. That was our step 1. We're then going to use step 2, which is to use the fact that these two lines are at right angles, so they're perpendicular. And perpendicular means that the gradient that we actually want to use, because we want to find the equation of the tangent here, is the negative reciprocal of what we just found. So m is not minus 3, it'll be positive, and it'll flip over to a third. Okay? And then the third step is going to be to use our general equation of a line. So that's y minus y1 equals mx minus x1. And we're using, obviously, m equals a third because we worked that out just now. And then the point we're going to use is going to be the minus 2, 6, because that's the only point which is on the tangent that we know about. So I'll have y minus 6 is a third x plus 2. Plus because it's minus minus 2. And then we could expand it, and if we really wanted, we could add that 6 across to the other side. And if we really wanted, we could simplify that to be, instead of 2 thirds plus 6, it could be 20 thirds. But you don't actually have to. If it just says find the equation of the tangent, this is enough. It's just if it says give it in the form y equals. So that's the general idea. We're going to look at one more example, but it's always that 1, 2, 3. Gradient of the radius, use the perpendicular negative reciprocal, and then find the equation of a line. So you have a go first on this one, okay? I'm going to show you the answer, but you should have paused in 3, 2, 1. Okay, so first off, this has a radius of 5 for whatever it's worth. I don't think we end up actually having to use that, but we'll see. So let's say r equals 5, because obviously r squared is 25. P, we know that it's got the x coordinate 4. We don't know what its y coordinate is. And that's going to present some issues. But let's try and do step 1. I want the gradient of the radius. So let's draw our radius on. We know it's at right angles to the tangent. and we know that we want to find basically how far across and how far down that is. It's going to be a negative answer for our gradient that we get. And here we run into the issue. We know that's 4 squares across because we've got x is 4, but we don't know y. How are we going to find y? Well, we're going to have to use the equation x squared plus y squared is 25. How are we going to use it? Well, we know x is 4, so we can say 4 squared plus y squared equals 25. And then what could we do from there? Well, that would tell us 16 plus y squared is 25. Take away the 16, y squared equals 9. Now, what can we do with that? Well, square root, obviously. But would it be true to say y is equal to 3? Could this coordinate be 4, 3? And the answer is no, because look where it is. It's below the x-axis. So we're actually going to take the negative square root and say that y is minus 3. This is combining, obviously the algebra says the answer could be 3, but the graph shows that it's got to be the negative square root that we take. Anyway, we've got our coordinate, so we know that this is 3 squares down, and now the rest of this is 1, 2, 3. So our gradient of the radius is equal to change in y, which is 3, over change in x, which is 4. It's negative though, because it's clearly going down, so our gradient is minus 3/4. Then we want the negative reciprocal, which would be 4/3. Flip it, change the sign. And then for our equation, we've got our coordinate, 4 minus 3. So we're going to say y plus 3 is, what's m? M is 4/3, yeah, we just got that. And then x minus, and then 4. Cool. As I say, you've got the marks at that stage. You don't need to expand this and simplify it. But if you're someone that feels like they have to, then it would go to, we've got to take away the 3 at the end of all this. 4/3 x, I think minus 25/3 or minus 8 1/3. Cool, so that's circles.